Alrighty. First things first. Okay. Constant speed, 30. Straight line as it passes point A. At A, it begins to... At A, the brakes of the train are applied. What does that mean about your distance time graph? Does it mean I say, oh, constant velocity first, deceleration second? Read the question really closely. What does it specifically want for me in part 1? A and B. Doesn't want it. It wants it to start at A. What happens at A? Starts to decelerate immediately, doesn't it? Some just carried it forward and then brought it down, right? So technically that's an error. It'd be whether the examiner is feeling happy with you or not. Okay? So technically you should be starting like this. Okay with that? So it decelerates from 30, which is up here, and it goes all the way down to what? 10. Alright. Not drawing the scale. Actually, I will draw the scale. Right. I'll bring it down here. Alright. Drag that all the way over. 10 would be all the way down there, wouldn't it? So reasonably sharp. And then drawing somewhat to scale. Now, the deal is, I don't know how long does it stay in the middle region? Alright, it reaches a speed of 10. The train travels at this speed per distance and then uniformly accelerates back to its initial speed as it passes the point B. So, do I know how long to make this? I don't. Give it an average. Whatever looks right to you. Okay? And then the next one, should I draw it like that? Why? Yeah, it's 1/3 the deceleration value. So, see this distance from here to here? It should be 3 times longer, shouldn't it? So what? So I should make it 3 times longer. So sort of stretch it out a wee bit, and then it reaches the top, like so. Now, that is a hint in itself, isn't it? Why is that a hint? It tells you something about the times, doesn't it? So, what I can say and what I've taught you what I taught you several times during the chapter was, I'll give you a very basic example. If I have an acceleration of 8 and a deceleration of 4, and we start and end at the same speeds, yeah? How much longer is the time spent decelerating compared to accelerating? Huh? It's twice as long, isn't it? Because you're decelerating at half the rate you were accelerating, and your start and end points are the same, it's going to take twice the time. So therefore, if I'm told my deceleration is 3 pi, but my acceleration is pi, what can I say about the 2 times here? This one's t, and this one is 3t. Anybody who went down this route, you did well. Anybody that tried anything else, it didn't really work out for you. Okay? Now, the next thing is the total time. How much total time is it? Here it is here, 4 minutes, which is the same thing as? Anybody? 240 seconds. Yeah. Now, what can you tell me about this middle time then? What do you reckon? Yeah, 240 seconds take away 4t. Reason being is they all have to add up. So t plus x plus 3t is 240. This implies that x equals 240. Take away 4t. Is that okay? So we have 240 take away 4t. Now, one of the easier parts is coming up next. 240 take away 4t. What do we know about the total distance of the question? You know about the total distance of the question? 4 kilometers or 4,000 meters. No bother. Okay, so this is my velocity time diagram. No bother. Now, what can I say about A, B, C, D, and E added together? What's A plus B plus C plus D plus C plus D plus E? 4,000, isn't it? Each shape is 4,000. Add them all together, you have to get 4,000. So let's start off with the area of A. What's the area of A? 20, because that's 10. That's 10. That's 30, which makes this 20. All right, let's start off with A. What's the area of A? A half what? T times 20. What's the area of B? 10 up, T across, so it's going to be 10T. What's the area of C? Anybody? Area of C? Yeah. 10 times 240 take away 4T. You just multiplied out, yeah, correct. Area of D? 3T times 10. And many people went down this route. Doing it this way, yeah. A couple of you there. Good man. And then finally, a half for E is a half 3T times 20. And you're going to multiply all these out. So what you're going to get is 10T plus 10T plus 2,400. Take away 40T. Oh no, you don't. Plus 40T. And 30T. And what's it? Another 30T as well. And this all equals 4,000. Now, what we're going to do is bring 2,400 from the left to the right. And we should get 1,600. And when we get that 1,600, so 2,400 goes to the right, we get 1,600. And then when we add all these together, we actually get 40T. And then we find out that T equals 40 days. What does it want from us? We still haven't got any, still haven't answered part 2, have I? Part 2 is looking for the value of pi. So I'm going to need to find the value of pi. So, to find the value of pi, what we're going to do is, it's the acceleration. I suppose we could do it this way. You can use phi equals u plus at if you want, but I'll try it this way. What's tan x equal to? The deceleration is 3 pi. 3 pi equals tan x, and what does tan x equal? We know the t value is 40. Opposite over adjacent is 20 over 40. This implies 3 pi equals a half. Bring down the 3, pi equals 1/6 ms squared. Okay with that? I can also use phi equals u plus at if you really want. So, phi value is 10. So, phi equals u plus at. For flip's sake. We can use phi value of 10, a u value of 30, an a value of 3 pi, and a t value of 40. And what we're going to get is minus 20 equals 120 pi. Pi equals minus 1/6. Technically speaking, it is, the deceleration is, you don't say a deceleration of minus 3, you say a deceleration of 3. So the pi value itself is 1/6. But when you say it's a deceleration, it's a negative value. Okay? So pi is minus 1/6. Ever killed that? Alrighty. Now, what's the next question? Calculate the distance travelled at 10 meters per second. Alright, that's easy. It just wants me to get the area of the green rectangle, rectangle C. Rectangle C was 10. Rectangle C was 10 multiplied by 240, take away 4t. We know t is 40, so 4t will be 160. This means you're only moving for 80 seconds, because 240 take away 160 is 80 seconds. So it's 10 times 80, which is 800 meters. You're moving for 800 meters in that section. Right. 2 points A and B are distance L apart. A particle starts from A and moves towards B in a straight line with initial velocity u and a constant acceleration k. A second particle starts at the same time from B and moves in a straight line towards A with initial velocity 4u and a constant deceleration of k. The time at which the particles collide in terms of u and L. Alrighty. Draw a diagram. A. Then you have B here. And A starts off with velocity u and acceleration equal to k. B starts off with velocity 2u. And oddly enough, B is decelerating, isn't it? Why is B decelerating? Because it's getting slower, right? So it's decelerating. Now, the times at which the particles collide. So somewhere in here, I don't know where, there's going to be a collision. Don't really know where to draw it. One of them's going faster, but it's decelerating. The other one's going slower, but it's accelerating. It's hard to say, so I'll just put it somewhere randomly here. Could be wrong, could be right. Don't know. Now, what do I definitely know? Can anybody tell me what does the blue line represent? Anybody know what the blue line represents? The distance travelled by A before you collide. Is that alright? And what about this one here? The distance travelled by B before you collide. Would you agree with that? So what's the formula that links the two of them together? SA plus SB equals what? L. There you go. That's your formula that links everything together. Let's do UVAS for both of them. So A will do a UVAS here. And B will do a UVAS as well. In green. Alright. First questions. We have the U value here. We have the A value. T is T. Are the times the same? Why are the times the same? What does it say at the same time? There you go. These values are the same. SA and SB. So, are we going to use V equals, do we use V equals U plus AT? I think we should use S equals UT plus half AT squared. And then substitute in for both S's. And see what happens. Let's find out. So, S equals UT plus a half AT squared. So it's going to be U times T for SA plus a half AT squared. That's great. SB is going to be 2UT. Then it's going to be plus a half minus K T squared equals L. What cancels? Two of them cancel, don't they? They're opposite in sign. So what we're going to get is 3UT equals L, and therefore time T equals L over 3U. For 10 marks. That's 10 out of 20 there. Okay. The first 10 out of 20 was quite accessible. The next 10 isn't. So, the condition satisfied by U, K, and L if the particles collide before the second particle returns to B. Alright. When you're faced with a question like this, it's best to think of it as if you know all the numbers. Okay? So imagine, for argument's sake, imagine that this is so imagine the scenario where B travels off its line, okay? A is traveling towards it. B stops, yeah? B stops moving, turns around and starts heading back towards its initial position. Is it possible for B to stop and start moving backwards? Why is it possible? Deceleration. So if the deceleration continues after rest, you can stop and move backwards. A is probably catching on it, but then B could potentially go back to its original point before A collides with it. That in theory could happen, couldn't it? Okay? And what's the other thing could happen? B is on its way forward, A is on its way forward, and they just collide then and there, don't they? That's one possible scenario. Next possible scenario is B goes forward as A goes forward. B stops, turns around, but A hits it before it reaches it back to its original point. Does that make sense? So you're looking at two different time frames. Okay? The time frame you need to understand is, if I have S equals 0 for B, what does SB equals 0 mean for B? What does it mean? It means the time taken for B for its initial, SB equals 0 means its displacement is 0. Displacement is 0. So B goes forward. So the first answer is T equals 0 because it starts off at that point, doesn't it? Then it stops and comes back again, and we can figure out how much time that takes. So for argument's sake, if that takes 20 seconds for B to come out and then return back again. But we know the collision takes place after 15 seconds. What would that mean? Does B reach home again? If the collision takes place after 15 seconds, but B takes 20 seconds to get back home, does B make it home? No. So essentially what we're looking for is, if the particles collide before the second particle returns, what you want is the collision time to be smaller than the time taken for B to return home. So that's how you do this. Collision time is less than time for B to return. Do we have the collision time already? What is the collision time? L over 3U. Now, how do you find the time taken for B to get back? Find out. We actually have it here. SB equals 0 is what we're looking for. So, S equals UT plus a half AT squared. S equals SB equals 2UT minus a half KT squared, no bother. We know SB equals 0. Multiply both sides by 2. And we got 4UT minus KT squared. Factorize out the T. We have T equals 0. We knew this already because we start off at that point. And then we'll also have 4U minus KT equals 0. 4U equals KT. And therefore T equals K over 4U. Go back down again. L is smaller than K over 4U. Oh, sorry. My fault. 4U over K. Bring K underneath, so T equals 4U over K. Bad. Alright, if you left the answer like this, there's nothing in the description of the question to tell me how you're meant to present it. So I would give full marks for that. Marking scheme, however, decided to cross multiply and have LK less than 12U squared. But I don't know how you're meant to know you're meant to do that. You're not. Okay. So that's your answer there. Anybody get that one out? I think there might be one lad. Well done, Alex.